Hello, everyone. Welcome. My name is Giovanna Scorsone. I'm the Education and Public Engagement Manager here at the Aga Khan Museum, and I'm so happy to have you all here on a beautiful sunny day after all of that rain. And I'm happy to welcome Bettina Forget, and she's going to talk to us about moon craters, exoplanets, and galactic revolutions. She'll be exploring art, space science, and the timely topic of women's representation, which is something we love to talk about here at the museum. It's particularly exciting for us with the upcoming 50th anniversary of the landing of the moon in just 2 days. Our big, beautiful moon festival that's coming up this weekend, our beautiful exhibition on the moon, where we take special care to look at the connections between art and science and faith. So, it's very timely to have Bettina here to talk about her work. It's also a time where we've spent the past few months exploring the contribution of women through art to society. So women with impact, as Bettina would say. So we're very excited to have her here with us today. And these universal themes are themes that are very important to us here at the museum, where we spend a lot of time looking at how we can connect cultures through art and promote pluralism, and how these cultures are timeless and universal, which, of course, so is the moon. We also take special care to acknowledge that the land on which the museum sits, Takaronto, is part of the traditional territory of the Anishinaabe, the Haudenosaunee, and the Mississaugas of the New Credit, in this place that has welcomed newcomers and new cultures, and we continue in that tradition with all of our programming here and what we celebrate here at the museum. And now, we continue that celebration of culture with Bettina's talk. Bettina is a Montreal-based visual artist, gallerist, art educator, and researcher. Her creative work focuses on space sciences and has been exhibited in the US, Canada, Germany, Iceland, Singapore, and Nicaragua. So lots of places. I'm glad she's here with us today. She is a researcher for the SETI Institute's Artist in Residence program, investigating the translation of ideas between collaborating artists and scientists. Very cool. In 2018, she joined the Convergence Perceptions in Neuroscience Initiative as Director of Fine Art. She's also pursuing a PhD in art education at Concordia University. So we are very happy to welcome you here today, Bettina. Please join me in welcoming Bettina to the podium.
Good afternoon. Thank you for joining me and spending your lunch hour with me. And thank you for the lovely introduction. So, as the title suggests, I'm taking you to the moon, I'm taking you to exoplanets, and then out into the cosmos. But I'd like to start my story here with my family. I come from a family of artists. Many artists who want to go to art school have to fight with their parents and convince them that this is what they want to do with their life. I didn't have to do that. We have artists in every generation, and this is a picture, I have proof. This is a picture of my great-grandfather. He's a charming gentleman on the left, with a beautiful beard, and he is showing his masterpiece that he did for graduation, and that is a portrait of his then fiancée and now my great-grandmother over here. And we still actually have this in our family archives. So making art was something very natural. My mother taught me how to draw and paint and how to do perspective from a very early age. But what I did have to struggle with a little bit was to convince my family that I wanted to do science. Because we have no scientists anywhere in our family, and I was collecting bugs. I was watching nature programs on TV with a clipboard, taking notes, like a real nerd. And I was very interested in astronomy. But nobody thought of giving this 12-year-old girl a telescope. So it took quite a while, until I was like in my late 20s. I gave myself a telescope for my birthday. And I never looked back. It's only, uphill from there. I was living in Singapore at the time, so I had to relearn what the night sky looks like. where everything's kind of on its side and further down. But when I came to Canada, I joined the Royal Astronomical Society of Canada, and it's just lovely to be with other astronomy enthusiasts. This is a picture of me at one of our outreach days at Astronomy Day, doing sidewalk astronomy, showing people how to use one of those little starfinders. I did even a stint as a president of the Montreal chapter, so it's very, very involved. And so over time, what I did during the day, which was making art, was starting to be informed by what I was doing at night, was astronomy. So now my creative work is entirely art that is inspired and informed by science, mostly astronomy. And a great place to start on your voyage to astronomy is with the moon. I'm going to see if I can make this. Yes. I love this animation because we think of the moon as a disk, because we only see one side of it. But I love this animation because it shows us the moon as a real celestial body, as a globe. And now we're seeing it in 3D. And I spent a lot of time looking at the moon. I live in Montreal, downtown, pretty much, so no deep sky observing, no galaxies for me. But you can always see the moon. Even you, don't care where you live, if you go outside on your sidewalk, even with a pair of binoculars, you can still observe the moon. And the moon, as we've seen, if you've been to the moon exhibition, which is just lovely, which I had a quick look at, it shows us that the moon is tied to us culturally. It's our closest celestial object. It's been talked about by poets and by songwriters. It's been enshrined in all kinds of art and culture and religion. So I spent a lot of time looking at it. I actually, don't tell the fire department, but I put my telescope on the fire escape, and then I look up. You get some very nice views, even from downtown. When you look at the moon maps, which I do a lot trying to find my moon craters, what struck me is how beautiful the names are of the largest features on the moon, which we call the Maria, the seas, because the first people who looked through telescope at the moon thought the dark spots were seas. So that idea kind of stuck. And you've heard of the Sea of Tranquility. The Eagle will land there on Saturday, 50 years ago. There's also the Ocean of Storms. There is the Bay of Rainbows. There's a sea of snakes. It's very poetic. So the first people who looked at the moon were very imaginative, trying to think of, what's going on up there. But if you look at the Moon Atlas, which I do a lot, this is the Ruckel Moon Atlas. This is like the go-to book if you want to know anything about the moon. Very nice close-up drawings. If you look at the craters on the moon, you'll notice that they are named after people, not snakes or rainbows. So I don't know how many amateur astronomers I have in this room, but anybody can tell me what that crater is? I know one person will know. So I'm looking at you, Kareem. But this is a very popular, large target, northern hemisphere of the moon. This is Plato. Has a nice, smooth crater floor, and this weird ear. So if you see that, that's Plato crater. And that's another beautiful crater. It has a nice central peak and terraced walls. That's also very popular. So that's Copernicus. And I like this one because of its large ejecta blanket. So you can see how different they all are. And that is, let me see, keep clicking on it. Okay, that's Kepler. So when I look at the Moon Atlas and I'm leafing through and I'm drawing some craters at the eyepiece, something that I noticed was they're named after great people. There's a naming convention on the moon that you name craters after scientists, after philosophers, after astronomers if you can. And then I noticed that they are all men. I looked through the Moon Atlas and said everything I've so far logged and drawn was named after great philosophers and scientists, but I wonder if there are any women up there. It's like, have I overlooked them? I'm also a researcher, so I went onto the website of the International Astronomical Union, pulled up the long, long list of all the moon craters that have been named. There are more moon craters up there, but those that have been named, we have 1,600. Wait. want to be on the right slide. 1,605. And I just gave away the punchline because I clicked this too fast. 30 are named after women. That is this much, 1.9%. It's a very small part of the pie. And I thought, well, how can that be? It's unfortunate. But is it really surprising? Because the moon doesn't just reflect sunlight. It also reflects all ideas and our thoughts and our sort of cultural preconceptions that we project onto the moon. And if you think of where you live, I'm assuming Toronto, maybe elsewhere, and in your mind, walk around your neighborhood and think about how many streets or monuments or parks are named after women. And my guess is that the percentage is probably around 1.9%. So as above, so below. Still not great. So what can I do as an artist? I decided to make drawings of all the moon craters that are named after women. I call this approach, instead of complaining, I call it protest by celebration. So I like to do something positive, just shining a light on the wonderful women that are there, and maybe creating more awareness of first of all, the situation that there's only 1.9% of women representation on the moon, and also maybe sort of promote the women that did get this distinction, having moon craters named after them. So how did I do that? I, first of all, needed to find out where all these moon craters are positioned, and about half of them are on the facing side, which then unfortunately meant that the other half on the far side, so I can't just sit there with my telescope. And the Canada Council for the Arts does give travel grants to artists. Unfortunately, not to that scale where I could go on a spaceship and sit there and sketch. So I needed a plan B. This is where the internet comes in. And the LROC space probe, which is still in orbit around the moon now, has a wonderful website. LROC is taking very high-resolution photos of the lunar surface. I mean, really, really fantastic, very sharp. And it even compiled all the archives of previous missions, so you can go through the Clementine missions, all kinds of other missions that sort of collect data about the gravitational perturbations on the moon. So I had the coordinates of all those craters, and what I did was just tap on the coordinates for Tereshkova Crater, for example. I zoom in a bit more, and then I play around with all the filters, because depending on when the photograph was taken, the shadows will be very different. So I wanted to pick something photogenic. This was a bit, very abstract. I was like, no, I'm not going for this one. That's what I settled on. And then I would do a screen grab, a printout, and use that image to create my drawings. So imagine music playing in the background. So this is me at my studio. And you'll see that I'm using acrylic paint to paint the shadows of the moon craters, and that is because there's no atmosphere on the moon. And on Earth, when you have a shadow, there's usually a little bit of refraction of sunlight that happens, but not on the moon. The shadows are velvety, punchy black. So even graphite has a little bit of silver in it. And so I wanted something that is totally black, so I used acrylic paint for that. And the rest, I just used different grades of pencils, and went into great detail and created my moon crater drawings. So the original series is just basically graphite and acrylic on paper. And that was me about like halfway through the series. I was going pretty much by alphabetical order at that point. And pinned them up in my studio just to give myself an idea. And you can see how different they all are. So my idea was really to create a portrait of a moon crater rather than, the way you would draw a portrait of a person. And what happens a lot in amateur astronomy, those who look through telescopes and are interested in moon craters, they will typically just take a photo And you can take beautiful images, even with holding your iPhone up to a telescope's eyepiece. If you have the chance, if you're coming back to the museum in a couple of days, I think you will get the chance to look through telescopes. And yeah, by all means, do that. Bring your iPhone, take a few shots. But you're looking at a moon crater, and you get a beautiful image, but do you really understand the crater? Do you understand how it's structured? When you draw something, it means you first have to understand its structure. And it really, really helps. When you draw something, it tattoos itself into your brain, and you will never forget what that crater looked like. So this is why I always encourage everyone to draw, and especially amateur astronomers. I actually give workshops on how to draw moon craters, because it really helps you to better observe what you're looking at and get a better understanding of the crater. And I know also on Saturday there will be how to draw moon crater workshops throughout the museum. So a little plug. Again, I'm looking at you, Kareem. I trained Kareem and his crew, and they're going to be out there encouraging people to try the handed drawing. And I always say, everyone can draw. I don't want to hear like, oh, I can't draw. Yes, you can. You have pencils at home. You can take a sheet of paper out of your printer, and you can draw something. So on Saturday, go try it. So that was Tereshkova Crater. Do you know who that is named after? Does the name Tereshkova ring a bell? Hang on. It's named after Valentina Tereshkova, first woman in space, and still alive. She is the only woman who has a moon crater named after her who's still alive. Normally, you have to be dead for a minimum of 3 years. So in case you're in your head thinking, oh, I know a couple of people, like, cool your jets, has to be dead for a minimum of 3 years. But because she's the first woman in space, they cut her some slack, so she has her own moon crater. She was a textile worker and parachute enthusiast before she became an astronomer. And she's still the only woman who's done a solo spaceflight. So very impressive young woman. She was up there for 48 hours in her Vostok 6. So it was, at that time, quite an accomplishment. And so many people think that the first woman in space is somebody else. This woman, Sally Ride, she's the first American woman in space, but also an amazing accomplishment. But notice that this was 20 years later. Sally Ride was the youngest person in space at the time. She was only 32 when she went into space. She did 2 missions. And in 1987, she withdrew from NASA, wanted to do more research. And she went to work on a project that measured the gravitational shifts on the moon, called the Grail Mission. And she was responsible to putting a camera on there. It's called the Moon Cam. And the Moon Cam was designed to get school kids really excited in astronomy. And they could propose projects of what they wanted to photograph there. So I love this because you always think of the moon in black and white. But astronomers, when they work with data, sometimes they put false color to better highlight what they want to look at. So this is the Grail mission. And if you Google that, like all these sort of crazy images come up in the rainbow colors. So what it does is the low topography measurement used lasers to determine how high something is on the moon. So how high are the moon craters, how like mountains on the moon, how deep are the moon craters? And then they compared with the Grail map that shows gravitational perturbations. The Grail really wanted to know what does the interior of the moon look like? And sort of these gravitational shifts, they're like an X-ray vision for a celestial body. And Sally Ride was sort of one of the PIs of this mission, and when that mission came to an end, they decided to crash that little space probe onto the lunar surface. Ideally, you don't want to have space probes floating around at the end of a mission, because we don't know where they'll end up, and they could maybe crash on Mars, and then it has all these nasty human space germs on them, and then we may mess up the ecosystem of another celestial body. So the policy is that when you have a space probe, you always want to crash it on a celestial body in a way that is controlled, and that will make sure that that probe totally burns up. And that's what they did with the Grail mission. And the impact site is now named after Sally Ride. So it's called the Sally K. Ride Impact Site. And so there's a bit of debate. I think we have 29 craters on the moon plus the Sally K. Ride Impact Site. It is so small that you can't even see it on any of the LROC data. So my drawing for that is just basically the general area where that probe went down. There's also a little debate whether the first woman in space should have had a proper crater named after her rather than a debris field of sort of mangled metal. But at least she has something up there. What is interesting that the Grail mission found something else. They actually found a crater, moon crater, a massive 124-kilometer moon crater that you cannot see. It is hidden. It is hidden under the regolith, under the sort of soil, under the ground of the moon's lunar surface. But you can see it when you're looking at the gravitational disturbances. And so the researchers who found this were situated at Purdue University, which also happens to have the largest collection of Amelia Earhart memorabilia. So no points for guessing what that crater is named after. Amelia Earhart. For those of you who don't know, so this, again, I drew a crater that you can't see, so I just drew the area where I know that the crater's underneath, and you're going to have to imagine concentric circles going out. So Amelia Earhart was a famous aviator, first woman to sort of cross the Atlantic. She did other crazy stunts like flying from Hawaii to Oakland in record time. She set all kinds of speed and distance records. Her crowning achievement was going to be circumnavigating the globe in her little Electra plane. And she did very well. She started off and made it all the way to Indonesia and then disappeared, which is why there's a question mark behind her date of death, because we just know that she crashed somewhere. She didn't arrive where she was supposed to arrive. Conventional wisdom is that she didn't have enough petrol in her plane and that she had very strong headwinds and she couldn't make it to her designated spot. That probably she went down on one of the thousands of islands that constitute Indonesia. But humans, the way they are, with their vivid imagination, if you read the right tabloid paper, there are all kinds of ideas swirling around about Amelia Earhart, that she was actually a Japanese spy, or that she was captured by the Japanese, or my favorite, that she was swallowed up by the Bermuda Triangle and then was transported to live with Elvis on the moon. That's a really good one. And I find it somehow really poetic that a moon crater that you can't see is named after a woman who disappeared. So when I initially started this project, I was just really interested in the women and wanted just to make a series of drawings of moon craters. But as I was drawing them, I was really struck at how different they actually look. Moon craters for me were just the holes in the ground, but each one has a very distinct personality. And I think in the end, it made a beautiful family portrait of craters and of women. And this series is now exhibited in Montreal. If you happen to find yourself in Montreal, I encourage you to go to the Montreal Planetarium. I always encourage people to go to the Montreal Planetarium. But in this instance, also because my work is exhibited there until the end of the year. So if you would like to see all the crater drawings, and all the bios. So an essential ingredient in this exhibition is also a short biography of each of the women after whom a crater was named. And they're really pioneers and women very much ahead of their time. So it was a beautiful project to work on. So we're going to leave the moon and going to venture out a little bit further. I did an artist in residence program last year at Mont-Mégantic. I don't know if you've heard of Mont-Mégantic. It's a beautiful observatory, 1,000 meters up, sort of 3 hours southeast of Montreal, close to the border with Maine. It's a natural dark sky preserve, so it's fantastic for deep sky astronomy, and it's a working observatory. They actually do real work there. They're associated with Université de Montréal, Sherbrooke University, and they have a couple of researchers from McGill. And they had this call for artists in residence, so I thought a smart move would be to just check what it is they're working on so I can tailor my proposal accordingly. And I found this, this quote about exoplanets. And as you heard in my intro, I'm working with the SETI Institute, Search for Extraterrestrial Intelligence. So the idea of life out there in exoplanet was already something that I was interested in. And what also interested me was that there's really no good way to classify exoplanets. At this point, I should say what exoplanets are. An exoplanet is any planet that orbits a star other than our sun. So we have the solar system, and any planet not in our solar system is called an exoplanet. And in the early 90s, we thought they were 0. Well, people thought there may be some, but we had evidence for none. By now, we have 4,000 that are confirmed. There's probably more out there, a lot more out there. But as this graphic shows you, but how do we classify them? So in our own solar system, we have the rocky planets, we've got the gas giants further out like Jupiter, Saturn. But what is interesting is that most of the exoplanets that we're finding have no equivalent to solar system planets. But the astronomers using the solar system to describe all the exoplanets. So they say, oh, we found an Earth-type planet, or a super-Earth, or we found a hot Jupiter if that planet orbits very close to its star. But it's not a really good system. So I thought, you have a problem, artist to the rescue. What can I do? What can I contribute through artistic means to help these astronomers come up with a better taxonomy for exoplanets? Nobody has ever thought of this. So this is one of the benefits of having an artist on your team. We show up with really weird questions. And they like this question, so they said, come and do this residency with us. So I called my project Exoplanet Zoo. And this is my proposal. I'm going to take a sphere, just a regular sphere, in a 3D modeling program. So if you've ever worked with 3D models in that kind of space, so you've got SketchUp or Rhino. So I used Rhino. So just a regular sphere with a couple of facets. That'll be my exoplanet. And now I'm going to mess with it. When you save an STL file, so if you do images, you get a JPEG. You're familiar with JPEG files. In 3D space, that file format is called an STL. But if you save it in ASCII format, which I found out after a lot of tries, and then you open it in a text editor, you get the code. Ooh, it's like me rubbing my hands together. Now I can mess with it. So what I've done is I took all these numbers and I plugged in exoplanet data. I went online, I found an exoplanet, and I said, okay, I'm going to take the most basic information about a planet, like its mass, its orbital period, how fast it's going, and I'm going to plug that into these data sets, this code. So basically, I'm glitching the sphere. I'm now making it do something else. And maybe by creating these different shapes, a new taxonomy will sort of suggest itself. So that's what it looked like at first. I was very happy with these. They look very weird. So this is not the way an actual planet looks. It's just a way to visualize data. They gave me these sort of crazy spaceship-like shapes, and I had a lot of fun with those. But unfortunately, they don't exist in real space because I'm pulling out coordinates from a sphere, and now it's no longer a real 3D object. But I had this idea of 3D printing them. And I wanted to make them into little sculptures so the scientists could actually look at them. So I went in and I closed up all those little vertices and did 3D print them. And I color-coded them so that those those planets that are orbiting very close to the host star are red, the water worlds are blue, the ice planets are, they are diamond planets out there. I mean, I'm calling it Exoplanet Zoo because exoplanets are really odd. Anything that you can imagine exists out there. So one of the actually most ubiquitous kind of planets are diamond planets because carbon is such a frequent, easy to produce element in the universe. So if you put it close enough to a star so it exists under great pressure, that carbon will produce diamonds. Actually, we probably have a whole bunch of diamonds below our feet right now. It's just very hard to get to. So yeah, diamond planets, I would love to see that in real life. And so once I printed them, I put them onto glass domes. So I'm sort of referencing back Victorian science. Science 200 years ago was something different than it is today. Scientists typically were interested in collecting specimen and then creating a hierarchy of what goes together and, man at the top, slugs at the bottom. So it was a different kind of approach to science. And people were very interested in collecting, like odd specimen, and then they put them on the glass domes, and they put them in a cabinet of curiosities. I love cabinets of curiosity. In Berlin, actually, there's an entire museum dedicated to cabinet of curiosities called Wunderkammer. Check it out when you're there. So I put all these planets in these Victorian glass domes and made a cabinet of curiosity, which I then exhibited part of that exhibition that came out of the residency. And actually, that initial exhibition is over, but we're representing again. Like, this has become a traveling exhibit, actually, because so many scientific institutions will become very interested in working with artists, and they saw the initial exhibition, said, this is really cool, can we borrow it? So right now it's going to be at Université de Montréal in their new science campus, and it's going to run late summer into early fall, again, if you happen to be in Montreal. So it was a lovely experience at Mont-Mégantic, and I would sort of basically hang out with the scientists. I would be in the residence, and at night I would spend time with them at the telescope. I should have included that slide where I actually was at the telescope, and I'm in the official logbook at Mont-Mégantic. But on rainy days, there's not much to do. So the scientists play board games, and I went down to what's called the Astrolabe, which is a little museum at the foot of the hill that is open to the public. The observatory actually is not. But so I saw this one room that is called the Cosmo Lab, and it's all about cosmology. And it was designed in the 80s, so it's not a beautiful museum display like you see here. It's basically you come into a room that is mostly black, and it has these backlit panels. It's basically like an astronomy textbook, splayed open, glued on the walls, and you just read your way around the room. So it's like, okay, it's a rainy afternoon, what else do I have to do? I knew a little bit about cosmology. I thought, let's find out a little more. And so I was reading my way around the room, and some more. And then I ran into a familiar problem. Let me show you what I mean. Yes. All men. It's like, no, I want to do exoplanets. But what am I going to do? This is not right. And especially if you're in the little waiting atrium, there are benches there, and they have pictures of their educational program, so they have a lot of kids in there. And I was imagining this group of school kids and all the girls looking around, and they're saying, oh, cosmology is just for guys, because all I'm seeing here is like the man and his universe. And it's like, well, maybe I'm wrong. Maybe there are no female cosmologists. Yes, they are. Even sort of in a quick Google will throw up a whole bunch of cosmologists, female cosmologists, who made considerable contributions to their field. So I thought, oh, well, I can't not do something. So what will I do? Protest by celebration. I decided to, copy exactly the museum panel, but make it all about female cosmologists. And actually, the guys in the museum, they were going, yes, do it, do it, do it. Nobody had thought of it. And I was asking the astronomers at top of the hill, give me a female cosmologist. Like, I don't know. It's like, you don't know Vera Rubin? She discovered dark matter. I was like, oh yeah. They're not in the canon, right? They're not part of the story. So I will tell you, so the way I did it, I wanted to do exactly the same panels, that they could swap out 2 existing panels and just put my panels instead. So there's an app on your phone that will track down the right fonts. So I went and said, that's the right typeface. I did some measurements. I did my layout. I did like an overlay, and after hours, I sort of taped it over the existing panels with my measure. I wanted to get it exactly right, and then somebody who shall remain nameless, who works there, tapped me on the shoulder and said, I know what you're doing. I have a PDF file. Should I send it to you? And I said, yes. So now I also have the right colors and the right background and everything, so it's an exact replica. I didn't just want to put the random stories of, a bunch of women who did cosmology, because then, again, I would be othering these cosmologists. They would be like an appendix on afterthought. So I thought, okay, what I'll do is I went through the exhibition and I thought, where are there holes in the narrative? And there's section on galaxies, which are really weak. I was like, that's my in. And so I found 4 women who researched galaxies, 4 cosmologists who work with galaxies. So I called this Galactic Revolutions. You see how I snuck in that revolution, because I'm a revolutionary, but galaxies also revolve. And so I made this whole thing about galactic research, and it just so happens that the 4 women, or the 4 people who made significant contributions to this field happen to be women. So this is how I sneaked in there. And they are really extraordinary. So I didn't put any of the names. Oh yeah. So I should have put names. So this is Beatrice Tinsley. There used to be this idea early on in cosmology that all galaxies are the same, that there are islands of light, and that they're just static. Beatrice Tinsley discovered that the kind of stars that make up a galaxy actually shape it. So we have different kinds of galaxies, and there's a whole evolutionary track for galaxies. And that had a big impact on what we know about the shape, the size, and the rate of expansion of the universe. So she made a very significant contribution. It's actually a revolutionary contribution to the science of cosmology. And this is the famed Vera Rubin, discoverer of dark matter. You probably hear this dark matter term being bandied around a lot. She discovered it, and the rate she did was she looked at the rotational speeds of galaxies. They look like spirals because they rotate. The weird thing about galactic rotation is that the outside and the inside rotate at the exact same speed. That's not possible. Newtonian physics said you can't. If you look at a wheel, or if you look at our solar system, Earth takes 1 year, Jupiter takes 12 years to orbit around the sun, Pluto is around, 248 years. So what happens in galaxies, the equivalent is that Pluto also only takes a year. So it's like, how can that be? So Vera Rubin said, what there is? There's extra matter that we cannot see that causes that speed up. So she discovered dark matter. And that was revolutionary because it really impacted how cosmologists understood the universe going forward. Then Sandra Faber came. I love this photo. This is so 80s. The big shoulder pads. I mean, sometimes astronomers have real style. So Sandra Faber looked at galaxies and how they move through space. So there's something called the Hubble flow that describes the Big Bang, and the universe expands, but it expands at a pretty standard rate. But by tracking about 300 galaxies in Cetus, in the constellation Cetus, she discovered that some galaxies really speed up and others kind of slow down. So there's some sort of massive thing in the universe that attracts and repels galaxies, which means that the Hubble flow isn't constant. It's a pretty big deal. What is really amusing is that her research group of 7 researchers was called the Seventh Samurai. And she was the head of the Seven Samurai. So I like how sometimes astronomers have a great sense of humor. Actually, the reason that she sometimes is forgotten is, when I did my research and I read up about this project, is that she's often referred to as one of the team members of the Seven Samurai. She was their leader. So this is how you can see how women are sort of filtered out of the narrative. And most sort of interviews were actually with her male colleagues and not with her. And last but not least is Margot Geller, who looked at the biggest structures that exist in the universe, galactic filaments. So the aforementioned black matter actually sort of creates these sort of large strings around which galaxies cluster. And Margot Geller said, if you look at the universe, it's a bit like soap scum, like soap suds. If you cut a slice through it, like that's the structure of our universe. So I thought that was a very interesting insight. So I love this. I've taken you from the moon to exoplanets to the galaxy. I did build the light boxes for Galactic Revolutions, and everybody from Mont-Mégantic came to see the exhibition, and they went like, this is so awesome. I have offered it to the Astrolabe. I said, I will gift it to you. You will have no reason not to have women there. I will drive it to Mont-Mégantic. I built it in a way there's no glue, no screws. You can take the light box or pop them out and put them in your display. I haven't heard back yet. I will persist. Eventually, they will have some women in there. So a wonderful SciComm website called Borealis, Science Borealis, asked me about the intersection of art and science, because it's such a weird thing. You think of, artists all weird in their, paint-stained clothes and being all subjective, and the, scientists in their lab coats and being all linear thinkers. But I think there's a lot of overlap, and it starts with this idea of exploration, discovery, and wonder. And I think that's something that we all share, that everybody shares, that you also share in this room. So I thank you very much for your attention. If you have any questions, you can bombard me now. If there's something that you think of on your drive home, feel free to send me an email. I'd be happy to chat. Thank you.